Welcome to an experiment which is based on something that Dr. Deming had talked about long back. This is something which is called the funnel experiment of Dr. Deming. The basic idea behind this experiment is, or the simulation if you'd like to call it, the basic idea behind this is to illustrate the nature of variation, and this variation is found in all kinds of systems, whether we talk in terms of our manufacturing processes, whether we talk in terms of our economic systems, whether we talk in terms of anything else that we do on a daily basis. And as you would be aware, Dr. Deming had really spent a lot of time really trying to educate people on the true nature and the true behavior of variation, because unless you really understand variation, the kind of countermeasures, the kind of reactions that we have to fluctuations, to variations, sometimes can be counterproductive. And the funnel experiment is designed to illustrate precisely this kind of an overreaction on the part of people to what Deming calls natural variation. According to Deming, there are two basic types of variations, or two causes of variation in any process. One which he calls the common causes, and the second one is what he calls special causes. Common causes are those causes for variation which are inherent in the process itself. Every process has a certain inherent built-in variability, or variability from whatever is the target. Now, you cannot really change the natural variability in the process by making small adjustments here or there. The only thing that you can do to change the natural variability of the process is by actually making a systemic change in the system that governs the behavior of the process. You cannot ask the people on the shop floor to make sudden changes, or if we have some knee-jerk reaction to a random variation. And that is what this particular experiment is going to demonstrate. What we have over here, as you will see, is a little setup where we have a little contraption that holds a funnel in place, okay, and this can move up and down, and I can also move it in this dimension, okay. I can also move this up and down, but this is the lowest level that this would be. All right, now I have drawn on this sheet of paper a grid which you can probably see, and my objective is I'll be dropping marbles from this funnel or through this funnel, and the objective is to try and get the marble to come to a stop at the point where the two lines meet, which is my target position, okay. And we are going to see different approaches in trying to make this happen, and we'll try to analyze what is the effect of doing various or taking various actions in trying to achieve that particular goal. Okay, so let's first, and we'll mark each point where the marble comes to an end or to a stop. So let's start. I'm going to take the marble and just drop it. Right now the funnel is positioned right above that intersection point of the two lines, which is my target. Okay. So my marble has come to a halt over here, so I'm going to mark this position with an X. Okay, I will drop it again without moving the funnel from this point. Okay, the target is still the same. So the second point now is marked with another X. Okay. The funnel is still positioned above the intersection point. this is my third point where the marble comes to a stop. Okay. All right. So what do we observe so far? Okay. Can we just bring the focus in on the individual data points, which are the places where the marble has come to a stop. Note that this was the target, which is the point of intersection of the two lines, and none of the places where the marble has come to a stop is the place which was the target. Okay. This variation of the stopping point of the marble in relation to the original target is really the cause due to what Deming called as the common causes, which is the natural variation in the process itself. Okay. Now what we are going to do is, well, let's do a few more of these and see if we get any better in terms of hitting the target. Okay, we'll just do a few more. It's kind of interesting that what you'll see is that a lot of the points are in this region and there are a few on this region and there's nothing on this side. Okay. Ah, I've got it exactly on the previous point, so I'll just mark another point right there. Ah, so this one really went out of bounds, so I'm just going to mark a point close to the boundary where the marble went off bounds. Okay, I'll just do one or two more. Okay. And after this one, we will take a short break and do a little readjustment, and then we will come back and try some alternate strategy. Okay. So again, let's focus on these data points, and what you'll see is that there is quite a bit of a spread in terms of the position where the marble comes to a stop. So what we're going to do here is we'll take a short break and we'll make a few adjustments here, and we'll come back and redo the thing with a few different rules. In the first segment, what we saw was what was the effect of dropping this marble through the funnel onto the table surface. What we saw was that the marble came to a stop at different locations, which was dictated by the natural variation of the process itself. Now in practice, when we don't hit the target, for whatever reason we are off in one direction or the other, generally speaking, management tries to take some corrective action. And what we are going to do is we are going to try and see 2 or 3 different types of actions or policies that are often taken by management in order to take some of these corrective actions, and what is the effect of taking these actions. In the first one, what we're going to do is, when I drop the marble and it comes to a stop, now let's say I have my target position. Initially my funnel will be focused on the target position. When the marble comes to a stop, let's say 3 inches to the right of that target position, then what I will do is I will move the funnel 3 inches to the left, because I will say that there is a tendency of the marble to come 3 inches to the right, okay, and then I will drop the marble again, and based on where the marble comes to a stop in relation to the new position, I will again keep readjusting the position of the funnel. In the previous example, or in the previous segment, we kept the funnel positioned at only one location. We did not move the funnel. This time around we are going to move the funnel, and let's see what happens. So in the beginning we start with the funnel positioned on the target position, which is the intersection point of the 2 lines, and I'm going to drop the marble again. Okay, so this is the first drop. Yeah, I hope we are getting the location. Now what I'm going to do is I'm going to measure this distance of the place where the marble came to a stop, and it's about 15.5 centimeters, and I'm going to go 15.5 centimeters in the opposite direction, and this is where I will target the next drop. Okay, so I'm going to position the funnel. What I'm really doing is I am trying to compensate for the error, which is the distance away that the marble comes to a stop from the original target position. So I have compensated. I hope you can see this was the original error, and I'm compensating it by an equal distance on the opposite side. Okay, so I drop it again. This is my new position where the marble has come to a stop. Okay, now what I'm going to do is I will measure this distance. This is going to be kind of a little difficult, and I'm going to take an equal distance in the opposite direction. This is about 14.5, I'm sorry, this is 16.5 centimeters in this direction, so this will bring me right to the edge of the sheet over here. Okay, I think just to play it safe, I will not compensate completely on that side, or I hope it will not roll off. We'll see if it does, and I'm going to drop the marble. Okay, let me try this again. Okay, what I'm going to do is I will compensate a little bit less just to be on the safer side, because otherwise we would really need a table of a huge size, right? Let me try this again. Okay. So this is my new position, okay, and what I'm going to do is I will measure this distance, and I'm supposed to go off the table, which obviously I can't. Essentially, let's try and draw some conclusions from here, okay. So now we have 3 points, and now we're going to drop the marble for the 4th data point and see. The last point was over here, and let's see what happens. Okay, so this is my 4th data point. Okay, and what I'm going to do is I will now again compensate on the opposite side. This is about 12 centimeters away from the original point, so I'll take about 12 centimeters over here, and this will be my new target position. Okay, so I position it over the new target position, and I am going to drop the marble again. Okay, so this is my next data point, and what I'm going to do is I will again determine the distance from the previous target and compensate for it in the opposite direction. The distance from the target is about 6 centimeters, so I'm going to compensate for it by another 6 centimeters here, and this becomes my new target, okay, in the opposite direction. Ah, okay, pretty good. Alright, so this was the previous target, and this is the place where it landed, so I'm going to compensate in the opposite direction and bring the new target position over here. Okay, I think we have got enough data points now. If you were to take a look at these, do you think we did any better? Okay, if you compare the distribution or the variation of these data points, what you find is that the actual dispersion of the points has actually increased, and this is one of the things that Deming called tampering, where we had a natural variation in the process, which was due to the way in which the marble bounced on the table surface and then rolled off in one or the other direction based on the natural tendency of the marble to roll in any of the possible directions. By trying to compensate for the error in the location where the marble comes to a stop, we actually ended up making the system much worse, which is precisely what tends to happen in practice. Let's say, for example, we have missed the target in the previous month or the previous week, or let's say where we have been underfilling the boxes or certain containers with certain material, and we now try to overcompensate by overfilling them, and essentially what we end up doing is increasing the total variation in the boxes, and from a customer standpoint the customer is not going to be satisfied because now you are getting a much greater variation in the actual weights of the boxes that the customer receives. We'll do two more variations, so we'll take a break over here, and we'll come back and try another variation of this. We have seen two segments of this experiment, the funnel experiment of Dr. Deming. In the first one, what we did was we positioned the funnel right above the target position, and we did not move the funnel and kept on dropping the marbles, and as the marble came to a stop, we marked the position. In the second case, what we did is we compensated for the error in the stopping position of the marble from the previous target position, and by doing so what we found was that the actual variation in the stopping positions actually increases. Now in this third segment, what we are going to do is we are going to compensate, but the compensation is going to be slightly different. We will measure the distance of the stopping point of the marble from the original target position, which is the intersection point of the two lines, and that is where we will measure the compensation from. Okay, so initially we will again begin by positioning the funnel exactly above the target position, and we will drop the marble and see what happens. Okay, so I'm about to drop the first marble. What luck. So we are about an inch away from the target position. Okay, now what we will do is we will compensate for it by taking about an inch in the opposite direction, okay, from the original target position, and I'm going to drop the marble again. Okay, looks like the marble doesn't like to stop very much. Okay, so this is my next stopping position. Now what I'm not going to do is I'm not going to measure the distance of this from the previous target. I'm going to measure this distance from the original target, and I will compensate for it in the opposite direction of the target. So this is about 8 centimeters from the, or 7.5 centimeters from the original target. So I take a point which is 7.5 centimeters in the opposite direction, and this will become my new target, which I will try to hit with the or position the funnel over. Okay, so now my funnel is positioned over the new target position, and I'm going to drop the marble, and the marble comes to a stop exactly on that particular point, which is quite incredible. Okay, now I'm going to measure the distance and go back to, actually it is this data point because I had compensated for it exactly in the opposite direction of the original target. So now I'll position it over this data point, and I'm going to drop the marble. Okay, now we have this data point which we will now measure from the original target. It's about 8 centimeters away from the original target, so I'll take 8 centimeters in the opposite direction, and that comes over here. Okay, so I'm going to now position my funnel 8 centimeters away in the opposite direction, and I'm going to drop the marble again. Okay, again I'm going to measure. This is about 7 centimeters away. So this is my new target position. Okay. Ah! How would you believe it? It actually hit the target. All right. So I'm going to, now this is quite incredible because I think in all the times that I have done this, I have never hit the original target. But so be it. So now I'll position it over the original target again and drop the marble. Okay. Once again, I compensate for it in the opposite direction by about 6 centimeters. So it's going to be right about here. That is going to be my new target location. And I'm going to drop the marble again. Okay, it went off the table. So what I'm going to do is, just so that because compensating for these is going to be a little difficult, I'm going to try this again. Okay, I get a point very close to where I was, and I'm going to measure the distance and compensate in the opposite direction. So I'm going to come back here somewhere. This becomes my new target position. Okay. Now I'm going to compensate for this. This is about 27 centimeters away. So if I look at another 27 centimeters in this direction, I'll come over here. That's a little bit close to the edge, so I'm going to take a couple of centimeters away just so that we have something to work with. Hopefully it will not drop off. Okay, and we again drop the marble there. What we find is that the location now is over here. And again, if we compensate for that, we are going to get something over here. Okay, we can measure this distance, which is about 30 centimeters, and if we go in the opposite direction, it will be somewhere right about here. So let's just do one more. Okay. Let's just focus a little bit on the locations of the marble where it came to a stop. How does it compare to the first instance or the second instance? What we are seeing is that our actual results are getting progressively worse. In the first case, we had some variation. In the second case, the variation actually increased, and statistically it can be shown that for the second instance, the variation should be roughly about 40% worse. In this case, the variation has actually gotten much worse. Okay, so anytime when we are trying to compensate, which might be based on, if let's say these are the kinds of things that companies or organizations or countries might do. An example of this kind of compensation might be when two countries are in race with each other in terms of nuclear arms. And if one country increases the nuclear stockpile of its arms, the other country tries to reciprocate by increasing its own stockpile. So essentially what you get is a growth in the nuclear arms rather than an actual decrease, and the basic purpose of increasing your nuclear stockpile is to deter the other country, but the deterrence never takes place, which is what you see is an explosion in terms of the growth of that variation, and these are things which we'll also find, for example, if we have drug enforcement policies, where once you make the drug enforcement more stricter, okay, when you, let's say, reduce, in India we don't have so much of an issue of drug enforcement as it is with regard to smuggling of products. So when you make the availability of certain products more difficult, the price of that product, especially the contraband type, that price goes up. When that price goes up, it becomes more lucrative for the underworld to engage in those activities, so the actual level of those activities tends to go up. So whatever the policies are to try and counter certain things in more or less a direct knee-jerk type of reaction, the impact of that is actually the opposite, with the result that we see over here, that there is a actual growth or proliferation in the actual variation of the position where the marbles come to a stop. So what we will do is we will stop over here and we will do one more variation on this and see what is the impact of that on the place where the marbles come to a stop. Now in this fourth segment we are going to change the rule for adjusting the funnel. What we will do is, again, we will begin by positioning the funnel right above the target, which is the intersection point of the two lines. Now wherever the marble comes to a stop, the point where the marble comes to a stop will become the next target point. Okay, and this is the thing which we will keep on repeating. Wherever the marble comes to a stop becomes the next target point. So let's begin. Initially we have positioned the funnel right above the target, and we are going to drop the marble now. Okay, so the marble comes to a stop over here. So now I am not really compensating for any error, but this new point now becomes my new target. So now I position the funnel above the new target and I let go of the marble. Okay. And I let go of the marble again. This is kind of interesting. So this is actually, let me mark this point, it's slightly away, not really very far. Okay, so this becomes my new target location. This is strange, to say the least. So that becomes my new target position now. Okay, now this will become my new target position. Okay. Okay, so now we have another data point, and I'm going to position my funnel once more above this new data point, and I'm going to release the marble. Okay, I'm going to repeat the thing because it fell off the table. That becomes my new data point, my new target, I should say. Okay, we'll do this again. Okay. We'll take one or two data points more, that's it. Okay. Okay, I think that should be enough. Now, first let me explain what this phenomenon, or when we adjusted the funnel position based on the last stopping point of the marble, what does that represent? In practice, what this would represent is where we have let's say the last person who got trained in a particular task, when that person uses his training or her training to train other people. So whatever information that person has, whatever understanding he has, we don't have a standardized process of training people, but whoever was last trained on that is the one who trains the next one, then the next one trains the next one. So whatever is that last shall we say point of reference is then used as the standard. And essentially what we did not get in this, but what we are supposed to get, is a much wider spread. When you start to or when we have, for example, if we have cut a length of lumber, okay, and that length of lumber itself, the last length of the lumber becomes the standard for that particular length. So all subsequent lengths of the lumber are cut based on that particular length, and whatever is the last lumber that has been cut to that length is the one that is used as a standard. What you're going to get is that the variation in the lengths of the lumber are going to be much greater. Here for some reason our marble didn't quite cooperate, and we tended to get a slightly more clustered data points over here. Let me move this out of the way a bit so that we can see the various data points. And the whole idea behind this exercise that we saw, we started first with a funnel which was statically positioned at the target, and we kept on dropping the marble, and the marble kept on moving based on its natural tendency to locate itself. Theoretically, that is the best solution, because whatever is the natural variation of a process is something that we cannot change by making small adjustments. Now if we wanted to make an adjustment, okay, one of the ways in which we could have made that adjustment, which would have been through the system itself, is we could have sought ways to actually lower the funnel and bring it closer to the table surface. When the distance of the funnel to the table surface is reduced, quite obviously the bounce and the movement of the marble will be reduced. Now in practice, what this means in a lot of cases is capital expenditure, and management a lot of times is not very amenable to incurring capital expenditure, because then they talk about return on investment, and a lot of times quality people do not see quality as a significant return on investment when it actually is, because the customer otherwise is unhappy. But whatever other things that they try and do, which is go down to the shop floor, maybe admonish the people on the shop floor, admonish the supervisors, ask them to make, tinker with the process here and tinker with the process there. The net result of all of that is the actual increase in the variation and the lowering of the quality, as we have seen with the 4 different runs that we have tried. One where there was no change in the position of the funnel, which is reflecting the natural variation of the process, and then we saw 3 different ways in which we were what Deming called tampering with the process. That means doing some little bit of changes here and there, which actually does not have any meaningful improvement, change or effect on the process itself. One of the other things that we could have done is made this surface itself softer. If the surface on which the material is, or the marble is dropping, is softer, then obviously the bounce of that material or the bounce of the marble is reduced, and therefore it would come to a stop where we wanted to stop. But these are all things which, again, as I mentioned, represent investment, and management is always trying to find ways which they can avoid investment, and these approaches generally don't tend to work. And I think that is really the purpose of this experiment, and I hope that I've been able to convey that to you. Thank you very much.